Again, with radicals, and there's one radical, you want to isolate it. It is. And I want to get rid of the radical. So to undo a cube root, I'm going to cube both sides. So the cube and the cube root cancel out. And be careful over here, this isn't 9, it's 27. And now I'm going to add 7, and when I do that, I get 34. So does 34 really work? Again, just go back to your calculator, type it in. So cube roots under math. And if I do 34 minus 7, I take the cube root of that, do I get 3? And I do, so that one works. All right, so here with exponents, I need to just work backwards in the order of operations. So going back to my little sticky note. I only have one x, so I just have to get x by itself. So first, there is addition, subtraction to move, but it's in the parentheses, so I won't move it yet. Instead, what I'm going to do is I'm going to move the 3. Don't move it in, move it away. So that's my multiplication division. So I'm going to divide by 3. And that gives me 16. And now to get rid of the 4/3 power, I'm going to take it to the 3/4 power. So that becomes 12 over 12. And then I'm just left with x plus 1. And then I'm going to take 16 to the 3/4 power, which again, you guys, you can type that into your calculator, but if you look at this as a radical, you'll really be taking the 4th root of 16, which is 2, and it's also negative 2, because it's an even root of a positive number, and then I'll be cubing those numbers, and 2 cubed is 8, but negative 2 cubed is negative 8. So now to solve for x in either problem, I'm going to subtract 1. So here I get 7, and here when I subtract 1, I get negative 9. So do these both work? I'm not going to do this one in the graphing calculator because this is, I'd have to do a lot of editing in the window, so I'm just going to leave that one as is. I'll type it in. So I'm going to put 3 in, and then x plus 1. And then no, sorry, not x, I want to actually put in a solution. And now my exponent key and 4/3. Now if you have the old operating system, when you're about to type in the exponent, you have to wrap your 4/3 in parentheses. This one, you don't have to. And when I'm done, I get 48, so that one works. And then I'm just going to redo this, and I'm going to put negative 9 in. So rather than retype it all, hit second enter, go back to 7, and you want to insert, so second delete, negative 9. And then just hit the delete button to get rid of the 7. And when I'm done, I hope I get 48. And I do. So both of these answers work, no extraneous. All right, last one, I have a radical. This time I do have to isolate the radical. So I need to move the 1/3 and the 5. So when you're moving over, you're just working backwards in the order of operations. So first I'm going to add 5. And now to get rid of 1/3. To get rid of this, I'm going to use the reciprocal. So this timesing by 3 cancels out the 1/3. And that means I'm going to times this side by 3, and I get 15. And now that the radical is isolated, I'm going to get rid of it. So to undo a cube root, I'm going to cube it. And then I'll need to take 15 to the 3rd power. And I'm taking it to a power, so there's not an option of positive or negative answers. That's just this. Oops, equals. And now to get x by itself, I'm just going to add 8 to this amount. And I get this number, 3,383. So does it really work? Well, try typing it in. So first, to type in the 1/3, wrap it in parentheses. So there's my 1/3. And then I'm going to get the cubed root to appear. So math, choose the 4th option. And then I'm going to put 3383 minus 8. Now I got to end this. So on the other calculators, I'd have to use parentheses to end it, but on this one I can just hit the right arrow. And when I'm done, I hope I get 0. And I do, so this is a solution, not an extraneous solution. All right, on the graphing part, you will need to tell me first, describe the transformation. You're going to have to give me the domain and range, and be sure to graph the parent points. So square roots, I'm going to get the parent points first. So here's 9, 3. And then cube roots. So, and you guys should know these points. I won't be giving them to you on the test. So describing the transformation. So first, this is going to make it stretch. and this is going to make it go right, and this is going to make it go up. That's all I need. This is going to make it flip. If you want to say x-axis, even better. This is going to make it go left, and this one's going to make it go down. All right, so stretching. When you stretch it, it's best to use the T-chart that gave you these points. So 0, 0, 1, 1, 4, 2, and 9, 3. And these are just these points, but now I'm going to take them all times 2, the y-coordinates that is. So times it by 2, that's still 0, 2, 4, and 6. So once I get these points graphed, then they'll go right and up. So 0, 0 will stay where it is, but now it's going to go right 1 and up 3. And 1, 1 is going to stretch to 1, 2, but now it's going to go right 1 and up 3. And 4, 2 is going to go to 4, 4. Now it goes right 1, up 3. And 9, 3 is going to stretch to 9, 6, and it's going to go right 1 and up 3. And then it starts and it keeps going. So the domain and the range, so the transformation change I wrote up there, but this is starting at the point 1, 3, and then it's going to infinity, infinity. So the domain starts at 1 and ends at infinity, and the range starts at 3 and goes to infinity. All right, this one. So first, these are going to flip. So again, you can make your T-chart. Any flipping or stretching, it's nice to have the T-chart. So -8, -1, 0, 1, and 8. So when I basically take the opposite or multiply these by a negative, this becomes 2, 1, 0, -1, and -2. So these points are gone. But after I flip them, then they still have to go left 3 and down 1. So this point's going to flip to up here. That's now -8, 2, but now it's going to go left 3 and down 1. And this one's going to flip up here, but now it's going to go left 3 and down 1. 0, 0 doesn't do any flipping, it stays there, but now it goes left 3 and down 1. And this one's going to flip to 1, -1, but now it goes left 3 and down 1. And 8, 2 becomes 8, -2, and then left 3, down 1. So this is my new, I don't know how well I'll be able to connect this, but. As for domain and range, as x is getting smaller, y is getting bigger, and as x is getting bigger, y is getting smaller. So the domain goes from -infinity to infinity, but so does the range. So unfortunately, the way I wrote it, I have to write it twice, the way I set this up. Okay, and again, the transformation change I just set up here, so I'm not going to do that twice. All right, next part. This is what we just talked about in 5.5. We are adding or subtracting or multiplying or dividing or maybe even doing composition of functions. One thing we're going to have to think about on some of the problems, it doesn't appear here though, is the domain. So first thing I want to do is subtract these two. So I'm going to take f of x and I want to subtract g of x. And again, adding, subtracting, really picky, but I will be able to subtract these because they both have a radical x, but I'm going to add the opposite, so I have 2 of them. Here I have 4 of them. When I'm done, I have 6 of them. So here's my new function. And the best way is to write your answers like up here, but that's okay. All right, now I want to add them. So here's f of x, and here's g of x. And again, I'm able to add and subtract these because these are both radical x's, so when I'm done, I'm going to put my answer here, equals -2 of these square roots of x's. Okay, now I want to evaluate. I want to evaluate the subtracted one. So the idea is I'm going to put 16 in here. And when I do that, the square root of 16, you guys, is just 4. And then 4 times 16 is 24. So when I'm done, I get 24. But the best way to put your answer is right back into the original part. Okay, and this time I'm going to put 16 into this one. So I get 4. So now when I'm done, I get -8. But again, just go up here and put your answer there. All right, let's go ahead and get through this part. So multiplying. So multiplying the two, I'm going to take f of x. Sorry, I know it's a little wavy. Times g of x. And now this is exponent problems. This is like the front page. So what I'm going to do is, the parentheses are just holding them. There's nothing to distribute in. So what I'm going to do is multiply the things that are similar. So half of 8 is 4. Okay. And then I want to combine these bases. So I'm going to do a little moving here. But the only way to combine these bases is I have to add the exponents. So I need a common denominator between a half and a fourth. And that common denominator is 4. So this is just going to change into 2/4. So when I add 2/4 and 1/4, I get 3/4, and so my x comes along, and now I have a 3/4. And again, no issues with domain. I don't have to, well, there are, but I'm not asking you about it. And now I'm going to divide them. So f of x, there's a half. X to the 1/2, and then here's 8. X to the 1/4. So I'm actually going to deal with the exponents first. So here I would subtract the exponents, which already got that common denominator before. So now when I subtract them, I get 1/4, and whenever you subtract, it always ends up in the top, and it's going to stay in the top because it's a positive exponent. Now as far as 1/2 dividing by 8, I mean, there's many ways you could do this. Here's 1/2 divided by 8, which just becomes 1/2 times the reciprocal. So when I'm done, I get 1/16. The other thing you could do is this 2 is just going to drop down here, and the 1 stays up here, and you get 1/16. Either way, you get 1/16. You don't really need the 1 there. And I really should write the answer here, but I didn't do that on these two problems. I'll put it over here. And this one, yeah, just... I dropped the 1 there. Okay, so now I want to evaluate. So evaluating, I want to put 16 in. And I am evaluating. I'm not solving, you guys. It's only when you solve do you have to worry about 1 or 2 answers. So you can actually just type this right into your calculator. Without your calculator, you are taking the 4th root of 16, which is 2, and then you're taking 2 and cubing it, and you get 8. Don't look at it as 8 and negative 8. That's only when you solve for x. So when I'm done, I get 32. And here, when I put 16 in, so again, the 4th root, or 1/4 is like the 4th root of 16. And the 4th root of 16 is just 2. And then 2/16 is 1/8. So there's that one. And again, I should put the answer up here like this. Okay, latest part, newest part, last section of the book is you have to find the inverse of the following function, and then you're going to prove that they're inverses, or disprove on the next part by showing me that if you do the composition of them, you get to just x. So inverse, first two problems. First, h of x, make that y, and now I'm going to switch these x's and y's around. And now my job is to get the new y by itself. And again, whatever I'm solving, that's what I'm doing here, is I'm going to work backwards in these order of operations. So the first thing I need to do is move any addition or subtraction. I'm going to move the -4 because the +3 is in parentheses. So I'm going to add 4 here, it's gone, and I'm going to add 4 over here. So it's x plus 4, not times 4, but plus 4. Here's the other side, still there. Now I'm going to move the multiplication or division. So I'm going to move the 1/2 that's multiplying to the parentheses. So I'm going to times by the reciprocal 2. And that cancels out this side. But that means I'm going to take all of this, each of these things, times 2. So the x gets times 2, and so does the 4. And now I'm going to deal with my exponent, just going along. To get rid of a cube, I cube root both sides. So now what I have is the cubed root of 2x plus 8 equals, I'm going to run into the other box, y plus 3, and now I can deal with the stuff in the parentheses. I'm going to subtract 3. So when I'm done, I have the cubed root of 2x plus 8. Subtracting 3 outside of that radical equals y. And we did talk about that y can technically be replaced with the inverse version of h. so the -1, but you can leave it as y, that's fine. So that's my inverse. And you know, you should see some opposites. Instead of a cube rooting, instead of multiplying by half, they're multiplying by 2. The whole adding 3, subtracting 3, the 4 and the 8 changed because we dealt with a fraction, but there's still that inverse in there. Alright, so this one I want to get rid of, or I want to find the inverse. So again, this is y, so I'm going to switch them around first. And I'm going to get this y by itself. So the first thing I do is move any addition or subtraction. I won't do that because I have to deal with this exponent radical part first. So I'm going to move the 2, I'm going to divide by 2. Okay, so, I mean, you could write it like a half if you want, doesn't matter. Now, to get rid of the radical, I'm going to square this side, and then again, I'm going to square both of these. So this side, the square root and the square just cancel out. And then because there's multiplication division here, I can distribute this. Or you could look at it as 1/2 x times another 1/2 x. That's what the squared means. A half times a half is 1/4. Or you're just squaring this. So that would be the x and the x. You're squaring the 1, and you're squaring the 2. And now to get x or y by itself, I just add 5. So I'm going to add 5 to this side. And I just add 5. It doesn't get to add with anything because they're not like terms. And I have it equaling y. Again, you could change that into the inverse format with the -1. Oops, sorry. But regardless, this is my answer. Okay, how do you verify inverses? That's where you do the composition function. So they're using f and g on both of these. So with f and g on both of these, what I'm going to do is I'm going to take f and put it into g, and I'm going to take g and put it into f. This is not the correct way to write it. F going into g would look like this, and g going into f would look like this. But this is the way we kind of described it in class. So all of this is going to go in where that x is. So the 2 is still there, the squared still there, the 1 is still there. So I'm going to write the stuff that's still there in green, and what I'm going to replace the x with, I'm going to put in red. So the 2 is there, but the x is going out, and all of this is going, it's in its place. I'm going to put it in parentheses. And I still have the squared, and I still have +1. So your job, you guys, is to show me how you get down to just x, which is that line of reflection if I graphed this and this. And you can't just cross out everything but x. You have to show me in steps. So we are simplifying. When you simplify based on the order of operations. When you solve, you work backwards. But when you're simplifying, order of operations. So the first thing I want to do is deal with the parentheses. And the parentheses means I'm going to square this. Because this is just 1/2 multiplying this radical, I'm going to square the 1/2. And I'm going to square that. So here's the 2 just going along. 1/2 squared is 1/2 times 1/2. That's 1/4. Whoops. And then squaring the square root, those cancel out, so I'm just left with x minus 1, but I'm going to leave it in parentheses, and then I get the 1/2. Next thing I would do, so we're going to, no more exponent, multiply or divide. So 2 times 1/4 is 1/2. I still have even more multiplying, 1/2 times x and 1/2 times 1. So, boy, I'm going to go over here. So there's 1/2 times x and 1/2 times 1. And then the +1. And now what should happen is I deal with the adding and subtracting. So 1/2 and 1 is just 1/2. Oh, I'm going to go up here. Sorry, guys, I should have put this on a different paper. And my job was I should have gotten down to just to x, and I didn't just get down to x. So that means these are not inverses of each other, okay? So since I didn't get down to x on just this one, I'm not even going to bother with the composition of the other way, okay? So as soon as you don't get to x on one of them, stop. You don't have to go any further. And this was definitely a tougher problem, okay? Not an easy one, but, you know, that's okay. All right, let's try this one. So here I want to see if these are inverses. So slightly different way that they're approaching. This one's the same, but this one's a little different. So again, let's try f going into g and g going into f. All right, and if they are compositions of each other, I should get x on them. So let's start with f going into g. So first, all of this is going to go into here. So I'm going to leave the square root alone. So, but in for x, I'm going to put in parentheses 2x squared plus 1. And then what's still there is the minus 1 and the radical 2. And this is all inside the radical. So the first thing I want to do is deal with my parentheses, which I can't simplify those. So I don't really need the parentheses. So now I'm just going to go to all one color. I don't need the parentheses then. But now those I deal with exponents. Well, I can't square anything. So I'm going to start cleaning up. 1 minus 1 is 0. So now I have this. I'm going to clean up my multiplication division here. And then I just get the square root of x squared, which is just x. So in the first one, I had f go into g. Now I'm going to have g go into f. So the 2 is still there, but instead of x, I'm going to put all of this in. I need another hand here. And now all of this is going to be squared. So I'm going to wrap it in parentheses. And then I still have the plus 1. So simplifying, first my parentheses, the square and the square root will cancel each other out. Okay. Now after my parentheses and exponent, I'm going to multiply. 2 times a half, those cancel out. And when I'm done, the 1's cancel out. Whoops. So now that I'm done, I'm just left with x. So the fact that I got x on both of them says that these are inverses. Because I couldn't get to x on this one, I didn't bother with the other. They are not inverses of each other. And that's it. I'm going to use the last page as a different video. Okay, so final part of the video, you're asked to find the domain. And remember, the domain is when you have the 3 issues of x being in the denominator. Let's try to focus here. So that means your denominator cannot equal 0. X being an even radical, so what's inside that radical has to be greater than or equal to 0. Or you might have the 2 happening together, so that means you're just going to use the greater than 0 symbol happening. So the first thing we want to know is just to determine the domain of this function. So there's no denominator or even radicals, so this domain is just, one way we could write it is all real numbers, or you could just go from negative infinity to infinity. On this problem, we have x inside the even radical, so I want to take what's inside the radical and do this. So once I get x by itself by subtracting 4, the smallest value I'd ever put in a t-chart is -4. I would pick greater than -4. So now what happens when I start putting the 2 together? So right now this says that g is going to go into f, so all of this is going to go into here. So the x is going to go away. The 2 and the squared will still be there, but this is going to go in its place. So here's the 2, but instead of the x, it's going to go the square root of x plus 4. And then I still have it squared. So when I go for the domain issue, I want to go in its unsimplified format. And I still have the same issue that I had up here. There is x plus 4 inside an even radical, and whatever's inside that even radical has to be greater than or equal to 0. So my domain is, not 0, -4. So there's my domain issue. And so I might write that as it can begin at -4 and then get bigger. Now, as far as the function goes, I can do some simplifying. This square and square root will cancel out. So then when I'm done, I just have 2 with the x plus 4, and then I could multiply the 2 through, so that when I'm done, my final function is 2x plus 8. But I still have this domain issue. The other one, now f is going to go into g, so that means all of this is going to go into this x. So the square root is still there, but instead of x, I'll have 2x squared and then plus 4. So now I have a little bit different situation because I want to see what will, whatever's going to be in here has to be greater than or equal to 0. So what's going to happen is I'll take what's inside the radical and I'll set it with this. I'm going to subtract 4 first. Then I'm going to divide by 2. Let me go over here. And what's going to happen is I'm going to be taking the square root of a negative number. And if you guys remember, taking the square root of a negative number is imaginary. And what I'm saying then is that my domain restrictions will be with imaginary numbers. So we're only working with real numbers because we're graphing. So this one has no domain restrictions, and I'll explain it a little bit better in just a second. So I could write it like this. And again, the main reason why is because when you take the square root of a negative number, you're going to get imaginary numbers inside this domain restriction. But if you think about it, if you put any number in here and square it, you're always going to get a positive number. And then we take that positive number and add 2, it gets bigger. And we take that number, add 4, it gets even bigger. So you're always going to have some type of positive number inside of here that you can take the square root of, no matter if x is negative or positive. So that's why it's all real numbers, or negative infinity to infinity. As far as simplifying goes, this is it. I can't simplify this anymore, so it's going to stay the square root of 2x squared plus 4. These are not like terms. I can't add them. I can't take the square root of the 4 and of this because, again, addition, subtraction, this is stuck together. Adding, subtracting has very picky rules. Hopefully that made sense. And that's it. That's your review.